Solving quadratics by factoring. So if you notice, this one's already factored. The only difference here, remember when we solve, it has to be set equal to 0. So make sure you make a note of that, and I would highlight it. Must always be set equal to 0. You cannot solve these until they're equal to 0, because remember, we're just trying to find the solutions. We're trying to find the zeros or the roots. Remember, they're all called the same thing. So solve means finding the roots or the zeros. Well, remember, we call them zeros. Sorry, that's a really hard color. Or that's really hard to see. We call them the zeros because it's when x equals, or when it's equal to 0. Sorry. So if I type in this equation, yes, it's going to give me the zeros, but I just want to remind you real quick. So if we do x minus 3 and x plus 6, and we graph it. So remember, there can be 2 zeros on these, and it's when the equation is equal to 0. That point right there is at negative 1, 2, 3, 4, 5, 6, 0, and this one's at 1, 2, 3, 0. Okay, so x minus 3 and x plus 6 equals 0. So remember when we're solving equations, like if I have 2 plus x equals 4. No, let's set it equal to 0 actually. Sorry. So let's say I have x plus 2 equals 0. Remember, you want to find what x value you can plug into this equation that would make this statement true. So the reason we do that is, so what we usually do is instead of adding 2, we subtract 2. So we do the opposite. So x equals negative 2. So negative 2 plus 2 gives you 0. Well, that's true. So you always want to find a number that you can plug into the equation that makes this side equal to this side. So when we have it in factored form, x minus 3 times x plus 2 equals 0. There's actually going to be 2 solutions. Just like we found when I typed that in, there are 2 solutions. There are going to be 2 solutions here. The reason why is when you're multiplying, if you have 2, and these are just little side notes reminding you of things. So if I have 2 times 0, 2 times 0 is 0. Or if I have 0 times 40, 0 times 40 is 0. So what I need to do is set each of these parentheses equal to 0. Because if I can make this parentheses equal to 0, it doesn't matter what's in this parentheses. Same for this one. If I set this one equal to 0, it doesn't matter what's in this parentheses, because whatever's in this times 0 is going to give you 0. So you will always set each parentheses equal to 0. So if I take this first parentheses, x minus 3 equals 0, and x plus 6 equals 0. Then I'm going to add 3. Well, let me write this step. Then I'm going to just solve both. So I added 3. 0 plus 3 is 3. So x equals 3. And then I'm going to subtract 6 on this one. So x equals negative 6. So solve both. So you have this one and this solution. Remember, we just found those when we looked at our calculator. Negative 6 and positive 3. Okay, Now I'm going to go in and check just to show you that, sorry, I got really close to the mic. I'm going to go in and check just to show you that this truly does make the parentheses equal to 0. So I'm going to check by putting in 3 into both of the x places. So, of course, that pencil does that. So I'm going to do 3 minus 3 and 3 plus 6. You don't have to do this step. This is where you stop. But 3 minus 3 is 0. 3 plus 6 is 9. 0 times 9 is 0, so 0 equals 0. So that's what I mean by as soon as one of the parentheses is equal to 0, then it doesn't matter what the other parentheses equals. This could be 219. As long as this one's 0, my equation is going to equal 0. So that's the first one. Here's the second one. So if I use negative 6. So if I have negative 6 minus 3 and negative 6 plus 6, negative 6 minus 3, both of them are negative, so it would be negative 9. And then negative 6 plus 6 is 0, equals 0. And negative 9 times 0 is 0. So they're both equal to 0. So both of those are solutions. Okay? Now they're not always going to be already set up in factored form. That's why we call it solving by factoring. Sometimes you're going to have something that's x squared. This is example 2. X squared plus 6x plus 9 equals 0. Now, in order to solve by factoring, you're going to have to find those two parentheses that multiply, or the two binomials that multiply to get this equation. So I'm going to use the box. Nine goes in the last one, x squared in this one. Okay, we know that x times x makes x squared. We need to find two numbers that multiply to get 9 and add to get 6. So let's list the factors of 9. Factors of 9, we have 1 and 9, 3 and 3. Remember, you can find those by dividing on your calculator. Okay, so then I'm going to add them. 1 plus 9 is 10, so that one's out. And 3 plus 3 is 6. So I need to put 3x and 3x, because remember they're getting that middle term, that's why we have to put an x on them. So x times 3 gives us 3x, x times 3 gives us 3x. So our two parentheses would be x plus 3 and x plus 3. Okay, now I actually do the solving part. So now I start these steps where I set both parentheses equal to 0 and then solve. So I'm going to do x plus 3 equals 0 and x plus 3 equals 0. Okay, then I need to subtract 3, subtract 3. So x equals negative 3. And then subtract 3, x equals negative 3. Okay, now this one's a little weird because yes, we have a possibility of two solutions, but they're the same number. This is what a lot of you guys messed up on the last test. So if I do x plus 3, x plus 3, I'm going to also just do that original so that you can see that they're the same equation. They're just rewritten. There's the first one. And there's the second. You can barely see it, but they graphed on the same exact thing. Now, do you see how it bounces off? That's what I call it. So this is called a double root, and you should probably just write that down. It's called a double root or double zero because it's the same number. So it actually has the same solution twice. So it bounces off the x-axis at -3. So the way I think of it is it hits and then it bounces off. That's why there's two of them. So -3 is the only solution here. It just happens to be the same solution. Okay. The next kind, if I have, so it's example 3. So if we have x squared equals 11x minus 28. Now, remember that very first thing, you can kind of see it, must always be set equal to 0. These equations, before you can solve them, they have to be set equal to 0. You can't type in two separate equations into your calculator. So we need to set these equal to 0. So in order to do that, you need to move this 11x to the other side and the -28 to the other side. So right now 11x is positive. So I need to subtract it, and I need to, since -28 or -28, you need to add 28. So then it would be x squared minus 11x plus 28 equals 0. Now I can start factoring it. So 28 x squared, and these two boxes combine to get a -11x. Okay, we know that x times x gives us x squared. So we need to find the two things that multiply, or the two numbers that multiply to get 28 and add to get a -11x. So we know 1 times 28, and then 28 divided by 2 is 2 and 14. 28 divided by 3, that doesn't work. 28 divided by 4, 4 and 7. 28 divided by 5, 28 divided by 6, 28 divided by 7. I already have that one written, so that is the end of my list. Okay, now let's go ahead and add them. Let me find what color I want. I want pink. Okay, 1 plus 28 is 29. 2 plus 14 is 16. 4 plus 7 is 11. 3 plus 7 is 10, so plus 1 more is 11. So this is really close. The only problem is we need a -11. Now, since it's a positive when we multiply, remember both signs have to be the same, or it would end up being a -28. So they both need to be negative. So -4 minus 7. So if I owe you $4 and I owe you 7 for something else, -4 plus -7 would give you -11. So that's what I want. So it'd be -4x and -7x. So -7, -4. So x minus 4, x minus 7 equals 0. Set both of them equal to 0. So add 4, x equals 4. Add 7, x equals 7. So that is how you solve by factoring. You just have to, sometimes you have to set it equal to 0. Sometimes you have to factor it, like the very first one was already set like this. Those ones you just have to set both parentheses equal to 0.